Okay, part 2. So question 11, a cuboid is shown on a 3D grid. The point P has the coordinates 2, 3, 4. The point Q has the coordinates what? Well, if we think about this line down here, if that's 2, 3, 4, so our x coordinate is 2, our y coordinate is 3, and our z coordinate is 4. So if this is our x-axis, has our x-coordinate of Q changed compared to P? No, they're both the same distance along. So we know that Q, our x-coordinate, is also going to be 2. Let's have a look at y. Our y is our height, effectively. And actually, these are at different heights. In fact, this one is on the ground, on the floor. This one is going to be at 0. So we know our y-coordinate is 0. And let's have a look at our z-coordinate. So our z-coordinate is along this axis here. These two are both the same distance along the z-axis. These two are the same distance along the z-axis. Therefore, it's going to stay the same. So 2, 0, 4. 2, 0, 4 is this one here. Okay. Question 12. What is 180 written as a product of its prime factors? Now, I do this a little bit differently. If you don't like my method, have a look on Maths Watch. There's other methods on there. For me, I'm going to do the flower pot method. So I've got 180 in my box. What two numbers times together to make 180? So I've got to have 18 and 10. Obviously, you can choose another pair of numbers if you like. Neither of those are prime, so I'm going to keep going. 2 and 5. Those are now both prime numbers. So I'm going to draw a bubble around them. Make it into a flower if you like. 18, I've got 9 and 2. 2 is a prime, 9 is not. Keep 9 going, I've got 3 and a 3. So I'm going to write those out in order now. So I'm going to have 2 times 2 times 3 times 3 times 5. 2 times 2 times 3 times 3 times 5. Now let's have a look at our list. 2 times 2 times 3 times 3 times 5. There we go. We do need to be able to put this into index form, just in case. That would be 2 squared times 3 squared times 5. So we need to be able to do that, but also we need to be able to recognize it not in that form. Okay? What is 1 3/4 plus 2/3 written as a mixed number? Now, what I would do here is I'd make this into, there's other ways of doing it, but what I personally would do is I'd make this into a top-heavy fraction, okay, an improper fraction. So 4 times 1 is going to give me 4, plus 3 is going to give me 7. So I've got 7 over 4, which is this here. We can check that that works. How many 4s go into 7? 1 with 3 left over, okay? Plus my 2/3. Now, when I'm adding fractions, what do I need to remember? To make the denominators the same. So I'm going to choose 12 on the bottom of both. Now, what have I done to my 4 to get to my 12? I've times it by 3. So I've got to times the top by 3 as well. That gives me 21. What have I done to my 3 to get to 12? I've times it by 4. So times the top by 4. So that would be 8. So that's going to give me 29 over 12. Now, as you can see here, there's lots of them written in these mixed number forms. So I might have needed to convert this back into a mixed number. Actually, we don't because it's here. I'm going to show you just in case anyway. If we did want to convert this back, then I'd say how many 12s into 29? 12, 24, that's 2. And then how many leftovers? 5 left over. So it'd be 2 and 5 12s. Okay, in fact, I haven't read the question. I want the answer as a mixed number. That is correct, but it isn't as a mixed number, is it? Okay, so 12s into 29 go 2. 2 takes us to 24, 5 left over. So that is going to be our answer. Okay, so read the question. Okay, right. Total surface area of this cuboid. So for me, I'm going to draw a little sketch. I always do this because I'm not very good at 3D thinking. So I've got a shape like this, and that's going to be on the front and the back. Okay, so I've got one of these. So it's a 5 by 3. Yeah, 5 by 3 centimeters. And how many of these did I say I've got? I've got front and back. So I've got 2 of those. And then this shape on the end, it's a 4 by 3. And then how many of those have I got? I've got 1, and then on the other side as well, I've got 2. And then what other shape am I missing? The top and the bottom. So that's going to give me, on the bottom, I've got 5 by 4. And again, the same on the top. So I've got 2 of those. And I will always do this when I do a question like this. So the area of this rectangle here is going to be 15 centimeters squared, but I want 2 of them. Yeah. This one is going to give me 12 centimeters squared because area is base times height, but I want 2 of them. And this one's going to give me 20 centimeters squared, but I want 2 of them. So I'm going to have 20 plus 20 plus 15 plus 15 plus 12 plus 12, or you do the times in first, I don't mind. So 10, 11, 12, 13, 14, 2, 4, 5, 6, 7, 8, 9. So 94 centimeters squared. Okay. Ooh. Cool. But for me personally, I'll always draw out my missing the size just so I don't forget. And we can do a nice easy check there that we had 6 sides